right, so we're going to look at radioactivity, and basically we'll just build on to what do you think makes up the mass, or let me say, why is carbon called carbon?
Yes.
Yeah, so why do you think it's called carbon?
Is it because of the properties or characteristics that it has?
Yeah, exactly. And one of the main reason why we call an element a particular name has to do with the number of protons it has. Okay, so this is simply because of the protons of the protons. So how many protons does carbon have? Even if the mass number is different, as long as that element has 6 protons, it will be carbon. For instance, nitrogen has 7. So anything that has 7 protons, we're going to call it nitrogen.
Yes.
Yeah. So now I'm just building on what basically what we'll be doing today is this is just the ground, and I just want us to do more of calculations, but I want to build the ground so that you understand that. So now we know that any element will have a nucleus, right? And we know that what do we find in a nucleus?
I'm not so sure. I'm asking if it's the protons and the electrons.
So among them in the nucleus, you find protons. Okay, so in the nucleus, you find protons. For instance, carbon has 6 protons in the nucleus. The the nucleus has protons. The nucleus has protons, and it also has neutrons. Okay, so the number of neutrons does not matter. So, but for the stable carbon, the neutron has 6 protons and 6 neutrons. 1, 2, 3, 4, 5, 6. Okay, and the sum of the neutrons. So these white ones are representing neutrons, and the magenta there is representing uh, protons. Okay, so now the sum of the protons plus the sum of the neutrons, this gives us the mass of an element. So on the periodic table, you find down there, we have the the proton number. Then down there is the mass. So what you should know is that for you to have a mass, you need a certain number of protons plus the neutrons. So sometimes you'll be given carbon like this. Say we have 14 there. So they can ask you how many neutrons does this element have. So what do you think is the answer here?
How many neutrons? Not the mass number.
Okay, let's identify the how many protons does it have?
It has 6.
6. And we said what's on top there? What do we call that?
The mass number.
The mass number. And we said what is the mass number made up of?
The sum of the protons and the neutrons.
Very good. Now, given an element like this, what do you think are the number of neutrons?
8.
8. Very good. Okay, 8. So, meaning that there could be another carbon out there that has um, that has 6 protons, because remember we said protons define the name carbon, so 1, 2, 3, 4, 5, 6, but it also has 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this may go on. It can even be 13 neutrons. It can be 5 neutrons, and so on and so forth. Now, this is where the 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 topic rather of radioactivity comes in. Okay, so radioactivity basically talks about if this continues having a multiple number of neutrons, the entire element becomes unstable, and just like when something is very big, it becomes very unstable and it starts losing part of its neutrons. So in cases, there will be cases where an element will lose neutrons, so the neutrons will be lost from the element, meaning that the mass will decrease, because for an element to be stable, the pair of protons um, and neutrons should be almost the same. So if an element has 6 protons, the number of neutrons should also be approximately 6, so that the pair is the same. Otherwise, the element will be unstable, and if it's unstable, it starts losing neutrons, or sometimes the neutrons will turn into electrons and protons. Okay, so because the neutron is made up of equal positive and equal negative charges. So in cases where the element is unstable, it can start changing those uh, protons inside of it into electrons, or it becomes a proton itself, just to try to balance itself. Okay, so now when that happens, this is what we call radioactive decay. So some mass is being lost due to that. So some neutrons will go out, and so on and so forth. Yeah. So now, basically, the questions that I want us to look at today will be, given the original mass of an element, let's say we'll call it a mass original, what will be the mass of that element maybe after a year or so? So that is what I want us to look at, because this will be either decreasing mass, or maybe it will increase mass, but mostly it will be decreasing the mass. So, but after so many years, how much mass will an unstable element have? Okay, the the term that is used for determining how much a mass will reduce by half due to radioactive decay in a particular time. Can you tell us what that name is, or can you guess what that name is?
Half life.
Very good, very good. Yeah, so half life. So basically, we'll be looking at the half life of an element. Now, let me just put some questions here so that you can follow through. So we have a question like this here. Can you read for us the first question we're going to look at?
If the half life of iodine 131 is 8.10 days, how long will it take a 50-gram sample to decay to 6.5 grams?
All right. So as you can see here, I want us to identify things. We're going to call AF, which is the future value or the future mass. It could also be the future percentage. Then I want us to also identify A naught, which is the present, or we can just say AP, which is the present value. Then I also want us to identify the time that has passed by. Now the half-life. Okay. So when you read this question, what do you think we have been given so far when we look at these variables?
Initial mass for iodine.
Okay, what is the initial mass?
We've also 50 grams.
Yeah, so very good. So now we've been given AP. AP is simply the present value, which is 50 grams. Then what else have we been given?
That's AF.
Okay, which is the future value, right?
Yes,
Which is
6.25 grams
6.25. What else have we been given?
for the mass to decay. 8.10 days.
So now look at this. So what are they looking for in this question if we were to look at it carefully?
We're looking at how long it would take for the mass to reach 6.5. So we're looking for the time, I suppose.
Yeah, so we're looking for T, which is
The
the
time
time.
take.
So now this that we've been given, we've been told that the half-life of iodine. So the 8.10 days is the half-life.
Okay.
You get that, right? So now
Yes.
this formula that I'm going to give you works all the time for each of these questions that you have here. It will always work when you're trying to find maybe the so it can be either of these. You are given the future value, the present value, you're looking for time, and you're given the half-life, or you're given the time, and so on and so forth. So it's just about you knowing how to make a variable subject of the formula. Is that okay?
Okay.
Yeah, and the formula is um,
Yes.
the future value is equal to the present value, then half raised to the power the time over n. So this is the formula you need to remember. Is that okay?
Okay.
Yeah. Hope you're writing somewhere.
Yes.
Yeah. So it's just about
Yes.
plugging in and making either T, N, AP, or AF subject of the formula. The half there will always be constant.
Okay.
Yeah. So let's find T. So T is here. So you will say AF, which is 6.5, 6.5. Is it 6.25? 6.25
6.25.
will be equal to the present value, which is 50 grams, then half raised to the power the time which we are looking for over n, which is 8.10. Have you seen that, eh?
Yes.
Yeah. Now here, this is where you have to be very careful here. Okay, this is the point where you have to be very, very careful here. So you cannot multiply this 50 times this.
Times the half.
No, you can't.
Okay.
Yeah. So what you do first of all is you're going to isolate the 1 over 2 to the power t over n. What we'll do is we'll divide both sides by 50 and this side by 50. Okay. So this
50.
50 and this 50 will cancel out and will remain with 6.25 divided by 50. What are you getting?
6.25 divided by 50 is giving me 0.125.
0.125. So equal to half to the power t over 8.1. Now, how do you think we're going to get this t down? How can we get the t down?
I'm not so sure.
All right. So there is a logarithmic property. I'm not sure if you've done logarithms, but you have log of a number raised to a particular number like that. So this is the same thing as that number that it is raised to. So the number drops down, then log of
Okay.
the base like that. So it's a logarithmic property, but you just have to memorize it like that since you guys have not done it. Is that okay?
Yes.
Yeah. So same applies here. We're going to introduce log both sides. So we're going to say log of 0.125 equal to. So immediately when we introduce log, the power will drop. Okay. So it will be t
Yes.
over 8.1 log of what is inside here, 1/2. So that is the only
1/2.
yeah. So that is the only way you can drop.
So when the is this the part t over 8.1 drops, it becomes a fraction, or
Yeah, no, it drops as it is. You see,
I don't know.
it is dropping as it is. You see t over 8.1, right?
Yes.
Yeah, so it is dropping as it is. So it drops as it is. Like you saw here,
Okay.
yeah. So it is dropping as it is. It will be t over it 8.1.
Okay.
Yeah. So that is always how you're going to drop if there is need to drop the power there. So that is always how you're going to drop. So dropping will also be done if you're looking for n, because you want to make n subject of the formula there. So now here what you do is you divide both sides by log of half and this side by log of half. Okay, so that you isolate the t over 8. So this and this will go. Then on your calculator, I'm sure you can see the log function, right?
Yes.
Yeah. So just find open parentheses log of 0.125 divide by, then make sure you use parentheses, right, when dividing. Or just say log of that, you find the
So
answer.
I'm starting with log, or I'm starting with the number.
The one on top. So log of 0.125, you find the answer, you divide by log of 0.5.
Okay.
And what is it now?
Right. Just a minute. 3.
So it's giving you 3, right? There is no decimal.
It's giving me 3. Yes.
Okay, excellent.
No, it's a whole number.
It's a whole number. 2
Yes.
t over 8.1. So how do you make t subject there?
8.1. We cross multiply.
Very good. And what will be your time?
Mm, 24.3.
Yeah, so the time will be 24.3. Now, the units of time would depend on the units that we have here. So if you check our question, the units were in what? In days.
Days.
Yeah, so even here, the unit of time will be in days. So that is how long it
Okay.
will take. Hope you've copied that.
Yes, I have.
Even the question, right?
Yes.
All right, now I want you to solve 5 by yourself.
Okay.
So what is the formula? Can you need to memorize the formula. So the good thing about the formula is that even in the exam, you just have to remember there is no need for you to be tracking that method of half of this, half of this. You see that method there?
Yes.
Yeah. Oh, let me write it down here. AF is equal to AP. Mm-hmm,
Open bracket 1/2.
mm-hmm.
Close bracket T/n to the power T/n.
Yeah. Then what have we been given in the formula? What is AF? What is
We
AP?
have we have AP,
Mm-hmm,
which is 848 grams.
mm-hmm. Then
Then we have N, which is the half life,
mm-hmm,
which is 12.4 hours.
mm-hmm. Then
And we have the time,
mm-hmm.
which was 62.0 hours.
Okay. Yeah.
Yes, but we do not have AF.
Yeah. So this one is a straight giveaway. Another thing to note, just another thing to note, you should make sure that the time and
Mm-hmm.
the half life have the same units, because sometimes you'll be given the half life in days, then the time in hours, then you're asked to find the present value for the future value.
Okay.
Yeah, so that's one thing to note. Yeah, so our future value will be equal to
AP, which is 848.
mm-hmm,
Open bracket 1/2.
mm-hmm,
Close bracket to the power 62/12.4.
mm-hmm. Then our AF will be equal to
So I should first punch the one that has a power, right?
excellent, excellent.
1/32.
So when you simplify this, that has a power, it's 1 over 32.
Yes.
Yeah, so it'll be 848 times 1 over 32, which will give you
26
mhm.
over 1/2.
And what is that in bracket? Just you see where you have SD on your calculator there, right?
SD.
Or where there is AB over C.
AB over what?
Over
AB
C.
over C.
Yeah,
Okay. That's 26.5.
yeah. So now what would be the unit?
This is going to be grams.
Excellent. You see how easy these questions are, right?
Yes.
Can you fail this in the exam? I'm sure.
No, but if you bring the test paper according to what we've learned, we can pass. But you like to manipulate the questions.
No, you just no. The thing is, you are tested for understanding. Okay. So, for instance, the
Mm-hmm.
understanding here is that the time and the half life should have the same units. If they are all in hours, they should understanding number one. Understanding number two, maybe you make a mistake on multiplying this fraction. Okay? You make a mistake on multiplying this fraction, it means that you're going to fail the exam. So others, this is why I even highlighted when starting, because many students will say 848 times half, then to the power 6, but that is totally out of context. Is that okay?
Okay.
Yeah, so
Yes.
even when you're studying, you should understand why things are happening. Okay, so like here, we see that we cannot multiply 848 to 1 over 2 because 1 over 2 has a power. So this is a number before you multiply it to that. So that is basic
Yes.
understanding that you need. Then I'm going to, so for this question, I'm sure you if you're asked to find AP, if you're asked to find N, you can do that, eh?
Yes.
Yeah. Now let me put you to a test, to a question that I have here. Okay, so I have a question here. Are you able to see the question?
Mm, yes.
Can you read the question?
Cobalt 60 is a beta emitter used in medicine. It is created in a nuclear reactor and decays with a half-life of 5.2 years. It is stored in a lead container until it is used.
Then down there is a question in red.
How long will it take for it to be 17% of its mass?
Yeah. So this question is actually similar to the questions that we've done. Okay, similar to the questions that we've done. So first of all, let's remind each other the formula. So what is the formula for finding how much mass or how much whatever is remaining?
AF
AF,
is equal to AP, open brackets, 1 over 2, close bracket, to the power T over N.
to the power T over N. Okay. Are we able to identify the future value from this question?
The future value is supposed to be 17% of 60.
No, it's just 17%.
Just 17%.
Yeah, that's the future value. Then
Oh, okay. So you find 17% of 60.
no, just 17%. So question,
Okay.
yeah, so 17%. And what would be the present value?
60.
No, it's 100%.
No, wait. No. It's 100%.
Yeah. So for questions like where you have percentages and this, so you just pay attention to the vocabulary. Um, if we have 80% of carbon, for instance, so we have, that's the present, right? So if we have 80% of carbon,
Yes.
how long will it take for it to be 10%? So those key terms to identify tenses will help you. So how long will it take for it to be 17%? So 17% is the future value, and we can take the present value as 100%. Then we have been given the half-life, which is n,
They have
which is, what is the half-life?
5.2 years.
5.2 years. Then we are looking for time, right?
Yes.
Time again. So here on the percentages, you can just put AF as 17 equal to AP will be 100. Then half T is what we are looking for over N, which is 5.2. So you can work that one out. let's do it together. Sorry.
Open bracket 1 over 2. No. So it's going to be 100.
Will be equal to
Open bracket 1 over 2.
1 over 2.
Close bracket
Mm-hmm.
to the power t over 5.2.
Okay, that's good. Then here, what do we do?
So 17 divided by 100. That's going to give you 0.17
0.17
is equal to 1 over 2.
Okay, goes to 1 over 2 to the power t over 5.2.
Then we're supposed to do log of 0.17
Mm-hmm.
over log of 1 over 2. The other side of the equation is going to be t over 5.2.
So let's go step by step. Yeah, so here when you simplify, what are you having? Log of 0.17 divided by log of 1 over 2.
Am I supposed to round it off, or I should give you the whole number?
No, give me the whole number. You only round off at the end of solving a problem.
Okay, so that's 2.55 63 93 34 9.
Like that.
Yes,
Okay, so
equal to
equal to equal to what?
t over 5.
T over 5.
Equal to t over 5.
And what will be our t equal to?
So t is equal to. Am I rounding off, or I can give you the whole number?
So first of all, you give the whole number, then you round off in the next step.
Okay, so equal to 13.29
13.29
32
32
45
45. So you said 3245. Sorry, 3245
41
41. Then now you can say time is approximately to 2 decimal places. This will be
29.
29. Then what is the time in? Is it in days, in hours, in seconds, in minutes, in seconds?
Yes,
Time is in what? Years.
yes.
Yeah. So that would be years.
Okay.
Any questions?
No, so far what we've covered is clear.
All right. So I'll send you this worksheet and you can work out the problems.
Is the worksheet being sent on Google Classroom?
No, I'll just send it in the group because, yeah.
All right, thank you.
All right.
Uh,
Have a great day.
thank you.